Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies. Welcome to this latest episode of Dan's Vehicle Dynamics Corner. And folks, in this episode of Dan's Vehicle Dynamics Corner, we're in for a real treat today because what we're going to be talking about is designing a race car using ChassisSim. Now, to sort of kick things off, ChassisSim is primarily thought of a race engineering tool, and with the motor racing environment in its current format, that is primarily where it actually has been used. But one of the lesser known applications of ChassisSim is that ChassisSim has actually been used as a design tool. And what we're going to be talking about today is we're going to be giving you a roadmap of how you actually use ChassisSim in the design process, and really some perspectives that we've learnt over the years that's really going to help you out. So for those of you who are designing a race car, for those of you who are currently involved in Formula SAE teams or Formula student teams, and really anybody who's just really interested in wanting to explore various concepts about where motor racing can go, etc., today you guys are in for a real treat. Now, one thing to kick this discussion off, what I'd like to discuss is who has been using ChassisSim as a design tool. This isn't actually what we're going to be presenting today, actually isn't theoretical. What we're going to actually be presenting today is actually sort of reflections about how this has been used in the past, and on the basis of that, to give you guys some really good procedures to use it in the future. Now, first things first, the people who have some notable users who have used ChassisSim as a design tool has been Pilbeam Racing Designs. It's actually how I got to meet Mike Pilbeam and how he ultimately became my UK European distributor, because we met when he was in the process of designing the MP84. We talked about ChassisSim, and he said, well, look, why don't you come and do some work for me? And we did. We did some aero work on the MP84. It was pretty basic stuff, but it was still good enough to go, oh, hang on, this is some good directions. And since then, it's been used extensively in the Virage, the design of the MP98 Virage. It's also been used for aero target studies for their upcoming MP100 LMP2 car. So that's really been used in anger. The other notable partner that's used ChassisSim has been Orica. ChassisSim has been a pretty big cog in the LMP1, in the Rebellion LMP1 2014 Le Mans project. And in particular, the advanced engine features and curse features of ChassisSim has been used very extensively in that as part of that design process. So what we're going to be talking to you about today actually isn't theoretical. ChassisSim has been used as a design tool. If anything, one of my, not so much a regret, but sort of a sad reflection about where motorsport has gone is I would really love to see ChassisSim being used much more of a design tool, but unfortunately, in the era of spec formula and shrinking budgets, it has been primarily used as a race engineering tool, but it can be used as a design tool as well. Okay, let's talk about the preliminaries for design. First things first, I really want to ram home the point that nothing happens in a vacuum. And the reason I want to ram home this point is that, and look, we're all, as engineers, we're all subject to this, is the fact that everyone goes, oh, fantastic, we're going to design something new, we're going to throw everything out, we're going to design the latest, greatest widget. Folks, it doesn't work that way, and all I can say is I can tell you and I have learnt that from bitter experience. First thing I want to ram home, understand what you've got. And what we've got here is a ChassisSim overlay when we've gone through and we've done our projects properly, when we've gone through the tire modeling and the aero modeling process. Again, actual is colored, simulated is black. This is steer, throttle, dampers, front dampers, rear dampers, steer, and lateral acceleration. And the other point that I really want to ram home, and particularly I really want to ram this home to Formula SAE and Formula student guys who are watching this, even if it's complete crap, understand why. You've got to know why it's complete crap. And really, for me, one of the things about working through the modeling process on an older design, particularly using ChassisSim, it's going to tell you so much about what you've got. You're actually going to have a baseline to go off. Because, to quote a friend of mine who has been in the process of designing a Formula Ford, like we've talked about this a couple of times, and the fact that if you don't understand your tires, if you don't understand your aero, all that you're doing is just a glorified process of guessing. So really, I cannot ram this point home enough. Even if it's complete crap, understand why and make sure you do your modeling of what you've currently got. Remember, a lot of what goes on in motorsport, it is evolution, not revolution. I cannot stress that point enough, because as engineers, we like to create things, and also because most engineers are male, to quote the venture capitalist Guy Kawasaki, sometimes we have an inbuilt disadvantage. We have the killer instinct. If someone comes up to us, we've got a search engine that'll kill Google. Most guys will go, yeah, no worries, we'll do that. But the harsh reality, sometimes it's a lot better to evolve from what you've got and to understand what you've got first. And this is a must step in the design process. And if you ignore this, you're going to fall flat in your face. And all I can say is I've been doing this a while. Learn from my mistakes, because I went down this road and paid the consequences for it. Okay, let's talk about the preliminaries for the design process. In particular, what I want to talk to you about is moments of inertia. Okay, when we're doing track and wheelbase sweeps, one of the things that's actually forgotten is the whole effect of moments of inertia. And in particular, what I really want to ram home is basically what the moments of inertia look like. And as you can see here, it's a function. What the moments of inertia do is effectively it sums up the square of the distances from the CG of all the mass components. And really, when you start varying tracks and wheelbases, you've also got to take this into account. A really handy tool that I actually learned in second year structures is second moment of inertia is the moment of inertia of from the center of mass plus the mass times the radius squared. That's a really, really handy tool. Now, one of the things that I would do if I were you, I would incorporate this into a spreadsheet. So what you would have is a spreadsheet with your various components, whether it be your tires, your engines, etc., etc. And what you would do is basically have a generic thing where what you would do is put in your tracks and your wheelbases. And as you start to do that, you get some sort of estimates from your moments of inertia. If anything, you could almost do it as a function of, say, for example, if you already know what your moments of inertia are, you could almost do it as a function of if you know what your current baselines are, which would be your current track, your current mean track, and your current wheelbase. All that you would do is basically have the equation moment of inertia is I times baseline multiplied by track new on track baseline all squared. That's the way I would do it. But I would really encourage you to incorporate your moments of inertia into what you are doing when you start playing around with your tracks and wheelbases. And the great thing about ChassisSim being transient is that you'll be able to see that as you work through the design process. Prelims, springs and dampers. Okay, first things first, you start with known spring and damper rates. You don't get carried away. You don't get any brownie points for getting really clever. Okay, and I really want to ram that point in. A lot of what you'll wind up with spring rates isn't just dictated by ground clearances. It's also dictated by what the tyre wants as well. So at this stage of the game in the design process, don't get overly carried away with making your springs massively soft or massively spring. Ditto with dampers. You'll play with the spring and damper rates once you actually start running the car. That's where the springs and dampers really come into their own. So I really want to ram that. I really want to ram that point home, because I've just seen a lot of cases where people start designing a new car and they come up with these crazy spring and damper rates, and you just take one look and you just go, okay, this is just not going to work. So I really want to ram home that precautionary tale. Let's talk about the design process. In particular, what I want to talk to you about some tips for suspension geometry. What you want to be doing when you start looking at your suspension geometry is you focus on roll center migration and camber loss and gains. Do not focus on lap times. At this point in the game, they are irrelevant. You use the symmetric transfer load option in ChassisSim, and you look at the return suspension data. In particular, one of the great things about ChassisSim is what we return what the actual camber is, and the front-based force-based roll center, and the rear-based force-based roll center. So you can look at this until you're basically blue in the face. And one of the things that I presented here is some work I did on some suspension geometry design for a time attack car that I did some design work for. Would have been back in 2007. In particular, you'll see here what I did was that I basically did some design work where I explored replacing the McPherson front end with a double wishbone rear end. And what I focused on, as you can see with the black with the new change, I focused on really minimizing roll center migration and also minimizing minimizing camber losses, as well. So that really is a really good tool that you can use for the design of your suspension geometry. Okay, aero. This is something that really where simulation, whether it be transient or pseudostatic, really does shine. And in particular, in the transient world where it'll just take it to a whole new level. Okay, if you're starting from a clean sheet of paper, one of the things I would strongly suggest is that you would pick a template that most closely resembles your car. In particular, let me give you some rough rules of thumb here. If you're designing something like, say, an F3 car, for instance, use one of the ChassisSim F3 templates. If you're using, say, a GT3 car, one of the things I would strongly recommend, we've got a LP560 template, so I would probably use that as a start point. If you're designing any sort of high downforce open wheeler, any high downforce car, and that goes for either an open wheeler or a sports car, one of the things I would strongly suggest, start on the GP2 template, because you're going to get an idea in terms of what the pitch sensitivities are going to do. And one of the things I would do just to illustrate, one of the things that you can actually do in ChassisSim is, let me just bring up my desktop and let me bring up ChassisSim. If you click on, and let me load in the GP2 template just to illustrate. One of the things that you can do is if you click on, say, the edit downforce ride height maps, you can go to axes properties text files. Here you can actually, if you've got a rough idea of what the ride height bounds are going to be, whether you've got it from CFD, etc., you can scale it here. Is this perfect? No, but just remember, at this stage of the game, particularly in the design process, what you are after here is you are after a start point. And I really cannot ram this point home enough, because what the start point gives you is at least, it gives you something to put your fingers on and go, okay, this is where we're going from, and that's a theme I'm going to return to very shortly. Now, what we do is you click on the rear wing of ChassisSim and you adjust your global CLA and CDA to suit. So you basically go through and do your sweep. So what you're looking for is obviously optimizing the L on D targets that you need. Keep the aero balance where the weight distribution is or where it is on those currently spec'd aero maps. Also, too, to keep things simple so you don't have any crazy gearbox issues coming into play, use the CVT gearbox option. Just to show you where that is in ChassisSim, where the CVT gearbox is. If we click on ChassisSim, click on for CVT settings, you can specify your minimum ratios and your higher ratios. So, but anyway, the CVT settings are there for you to use. Now, the next point in the process is once you've specified your L on D targets and the CLA and CDAs you're targeting for, you move on to aero balance. However, I want to ram this point home really clearly. Do not get carried away and watch your actual versus neutral steer like a hawk. It's really because ChassisSim is the perfect driver, it does not know fear. It will tend to shift forward on the aero balance. And just remember, the last thing you want to do is come up with crazy aero balance figures that when you put in a driver, they're going to get scared. You don't want to do that. I would just keep it to within about, say, keep your search ranges to about plus or minus 5%. Now, just a quick word on the aero process. Even though I realise that this presentation is about how to drive ChassisSim, I want to make a few salient points about using CFD. Okay, first things first. If you're using CFD, do not treat it as manna from heaven. You've got to treat it as a start point. If anything, a very good friend of mine, Ray Leto from TotalSim, made a really good point about simulation. You've got to recognise actually how wrong the simulation is, and to be quiet, and that's coming from someone who I think is, quite frankly, the industry from a guy who, quite frankly, is one of the best CFD operators in the business. One thing I will say, that particularly if you do have a bit of money to spend, I would definitely see the boys from TotalSim. They are guys who are really, really on top of what they are doing. So I would definitely give the guys from TotalSim a call, particularly if you're engaged in CFD work. But everything that we've talked about aero, as I said, if in doubt, start from an existing existing aero map, and then you tune your L&D and aero balances appropriately and use your CVT gearbox. Okay, design process, engines. Okay, obviously, as we touched upon with ChassisSim being used by Orica, ChassisSim has pretty sophisticated models for engines and Kerr's hybrid. You move on to this once the aero has been defined. Again, tread carefully. I really cannot ram this point home enough. If anything, and the reason I want to ram this point home is the fact that one of the more disturbing features I've been seeing about computer-aided engineering tools is that a lot of people like to use them as magic wands. Just remember, what you're using is a calculator. You're not using a magic wand, and you forget that at your peril. Okay, let's talk about the process, about where you use ChassisSim and where it sort of slots in. First things first, you establish a solid baseline. If you don't establish a solid baseline, you're absolutely nuts. And I really cannot ram that point home enough. First things first, if needed, you establish your aero targets using your current engine spec. You then fix the roll centers and establish your front and rear tracks. If needed, you investigate your engines and your curves. You move on to your suspension geometry, and then you tune in spring, damper, and ride heights. That is pretty much, if I was designing a car from a blank sheet of paper, this is where I would slot using ChassisSim in. And I really cannot ram that point home enough. Again, folks, you don't get brownie points for showing how clever you are. ChassisSim is part of a careful, considered process, and you've got to use it that way. If you don't use it that way, then quite frankly, you are going to be completely and utterly wasting your time. But that process there, you establish a solid baseline, you fix your aero targets, fix the roll centers, play around with your tracks and wheelbases. Again, don't forget your moments of inertia. Move on to your engine and curve stuff. Move on to your suspension geometry. Then tune in with spring dampers and ride heights. And I really can't ram that point home enough. To sum this up, I want to really sort of give you some perspectives here. And the first perspective I want to give, first things first. Simulation is a start point, and I really want to ram that, and I cannot really stress that point home enough. And the reason it's a start point is that one of the most disturbing trends that I've seen in computer-aided engineering tools is that a lot of junior engineers and SAE formula students, I'm talking directly at you guys, do not, under any circumstances, and I cannot ram this point enough, any circumstances, think that an FAE package, a simulation package, replaces intuition. If you do, quite frankly, you haven't done your job properly. It's as simple as that. The other point I want to ram home, treat every run you do critically and understand the numbers you're putting in. Just like with ChassisSim as a race engineering tool, this is a calculator. It is not a magic wand. However, I will say to you this. If you use simulation this way, it's going to be a fantastic tool. However, Treat it as a calculator. Do not treat it as a magic wand. That being said, one of the things that I now want you guys to do is for those of you who are existing members of the ChassisSim community, by all means, throw some design exercises at ChassisSim and see where you get to and have some fun. For those of you who are not ChassisSim users, sign up for our online simulation and start playing around with start playing around with a few what ifs. To your formula the formula student or formula SAE students who are listening to this, we actually have a formula SAE template you can play with. So throw some mud on the wall and throw some mud on the wall and have some fun. And we'll catch you in the next episode of Dan's Vehicle Dynamics Corner.